Problem sheet 6, question 3. Toy Autos is a small car manufacturer based in Wales, producing 100 vehicles per year. They have 3 factories, one in Barry, producing 35 vehicles a year, one in Port Talbot, producing 45 vehicles a year, and another in Wrexham, producing 20 vehicles a year. They have 3 dealerships, one in Bangor, selling 15 cars a year, one in Cardiff, selling 70 cars a year, and another in Newport, selling 15 cars a year. According to Google Maps, the distances between each of the factories and dealerships is as follows. Toy Autos would like to know how many cars to send to each dealership from each factory to satisfy the supply and demand in each location and minimise the total number of miles travelled. Hint, begin by producing an initial feasible solution with the northwest corner method, then use the stepping stone algorithm. So we'd like to formulate this as a transportation problem, so we'll set up our grid. Our grid will be a 3x3 grid as we have 3 factories and 3 dealerships. So our factories will be the rows and our dealerships the columns. So we have Bangor, Cardiff and Newport. We have Barry, Port Talbot and Wrexham. Barry, Port Talbot and Wrexham can produce a certain number of vehicles per year. And Bangor, Cardiff and Newport sell a certain amount of vehicles per year. We can see that the dealerships sell 100 cars and the factories produce 100 cars. So we have equal supply and demand. And then according to the table, we know that the distances of each of these routes. Filling in the northwest corner method, we'll fill in as much as we can for the northwest corner. That satisfies Bangor, so we'll move east, which satisfies Barry, so we move south, which satisfies Port Talbot, so we move south, which satisfies Cardiff, so we move east, which satisfies Wrexham and Cardiff. We'll now perform the stepping stone algorithm, so we'll consider every non-basic variable. So the first non-basic variable we'll consider is the Barry-Newport route. This route begins here, and we want to make a loop from here back to itself, only turning at each of the basic variables. So we can go down to here, across to here, up to here, and back. That would involve increasing the Barry-Newport route at a cost of 25 per unit of goods, decreasing the Wrexham-Newport at a cost of 126 per unit, increasing the Wrexham-Cardiff at a cost of 140 per unit, and decreasing the Cardiff-Barry route at a cost of 10 per unit, which gives us a net change of 29. If we increased the flow in the Barry-Newport route, we would be worse off by 29 per unit. The next non-basic variable we'll consider is the Port Talbot-Bangor route. Our loop now would be from here and back. So we would increase the Port Talbot-Bangor route, decrease the Barry-Bangor route, increase the Barry-Cardiff route, and decrease the Port Talbot-Cardiff route at a net unit cost of minus 49. So that would benefit. Let's check all the other non-basic variables. Let's consider the Port Talbot-Newport route. That's here. And our loop would be this. So that would be increasing Port Talbot-Newport, decreasing Wrexham-Newport, increasing Cardiff-Wrexham, and decreasing Port Talbot-Cardiff at a net cost of 20. So that would worsen our solution. And finally, let's consider the Wrexham-Bangor route. From here, our loop would now be this. So increasing Wrexham-Bangor, decreasing Barry-Bangor, increasing Barry-Cardiff, decreasing Cardiff-Wrexham at a net unit cost of minus 254. So that's a huge decrease in cost. And we've considered all possible non-basic variables, and therefore we should increase the Wrexham Bangor route. What's the most we can increase the Wrexham Bangor route by? So if we're increasing this, we have to decrease this, increase this, and decrease this. So the most we can increase Wrexham Bangor by is by decreasing Cardiff Wrexham by 5. We cannot increase it by more than 5 because we cannot have a negative value, because we cannot send a negative amount of goods. So we'll increase this by 5, increase Wrexham Bangor by 5, decrease Barry Bangor by 5, increase Barry Cardiff by 5, and decrease Cardiff Wrexham by 5. We don't know whether we are done or not yet, so let's perform another iteration of the stepping stone algorithm, looking at every single non-basic route and seeing if it's worthwhile making those basic. So first look at the Barry Newport route. That's here. In order to create our loop, we would go down, across, up and across. So we would increase Barry Newport, decrease Wrexham Newport, increase Bangor Wrexham, and decrease Barry Bangor at a net unit cost of minus 225. That's a huge decrease. How about Port Talbot Bangor? That's here. Our loop now would be this. Increase Port Talbot Bangor, decrease Barry Bangor, increase Barry Cardiff, and decrease Port Talbot Cardiff at a net unit cost of minus 49. How about Port Talbot Newport? That's here. Our loop now would be this. Now we are going through every basic variable. So we would increase Port Talbot Newport, decrease Wrexham Newport, increase Wrexham Bangor, decrease Barry Bangor, increase Barry Cardiff, decrease Port Talbot Cardiff at a net unit cost of minus 234. And finally, let's consider Wrexham Cardiff. Our loop now would be this. So we would increase Wrexham Cardiff, decrease Wrexham Bangor, increase Barry Bangor, and decrease Barry Cardiff at a net unit cost of 254. So that would actually increase and make things worse. So the best possible move we have is to increase Port Talbot Newport. By how much? Well, we can increase Port Talbot Newport by decreasing Newport Wrexham, increasing Wrexham Bangor, decreasing Barry Bangor, increasing Barry Cardiff, and decreasing Port Talbot Cardiff. We are constrained by our decreases, so our biggest decrease is this 10. So we increase Port Talbot Newport by 10. Now we don't yet know if we have finished the stepping stone algorithms. We'll do it again. We'll check every non-basic variable. So first we will check Barry Bangor. Our loop now will be this. So increase Barry Bangor, decrease Barry Cardiff, increase Port Talbot Cardiff, decrease Port Talbot Newport, increase Newport Wrexham, decrease Bangor Wrexham at a net unit cost of 266. How about Barry Newport? I will loop now from here, like so. That would be increase in Barry Newport, decrease in Port Talbot Newport, increase in Port Talbot Cardiff, decrease in Barry Cardiff at a net unit cost of 9. How about Port Talbot Bangor? Here, our loop now would be this. So increase Port Talbot Bangor, decrease Port Talbot Newport, increase Newport Wrexham, decrease Bangor Wrexham, the net unit cost of 185. And then what about Cardiff Wrexham? Our loop now from here will be like so. So we are increasing Cardiff Wrexham, decreasing Port Talbot Cardiff, increase in Talbot Newport, decrease in Newport Wrexham, at a net unit cost of 20. All possible changes, so any way we could change a non-basic variable to a basic variable now, will result in an increase in unit cost, and therefore we have found our optimal solution.